Hi, this is Professor Sartor, and I'm going to work through a few more problems from my college algebra class. This question says, find the equation of the line passing through the points 2, 1 and -2, 5. Write the equation in point-slope form, slope-intercept form, and standard form. So the first thing we need to do is find the slope. You can find the slope using the slope formula. That's y2 minus y1 over x2 minus x1. We're going to label our points x1, y1, and x2, y2. It doesn't matter which one is x1 or x2. Only thing that matters is that you have an x and a y, and both of them are labeled the same subscript. So I'll substitute those into my slope formula. y2 is 5 minus y1 is 1 over x2, which is -2, minus x1, which is 2. So if we reduce, that gives me, or not reduce, simplify the numerator. 5 minus 1 is 4. The denominator, -2 minus -2 is -4. And now we can simplify 4 divided by -4 is -1. So now that we have the slope of the line, we want to write the equation in point-slope form. Point-slope form is y minus y1 equals m times x minus x1. So that's why I needed the slope. And then we have x1, y1, and that x1, y1 is any point on the line. So you don't have to stick with that first one. You could also use the second one, whichever one you prefer. So our point-slope form is y minus 1, I am using the same y1, equals m times x minus x1, so I'll use that 2. And that's the point-slope form. The only thing I might do is instead of writing -1, write negative. So that's our point-slope form. The next thing we want to do is write that in slope-intercept form. So slope-intercept form is y equals mx plus b. So I want to take that equation that I already found, y minus 1 equals negative x minus 2, and my goal is to get the y by itself. So I'm going to distribute that negative to give me negative x plus 2, carry down the y minus 1. Now to get the y by itself, I add 1 to both sides. That gives me y equals negative x plus 3. So that's my equation in slope-intercept form. Okay, so the last thing we need to do is write it in standard form. And standard form is when we have ax plus by equals c. We're going to have both our x term and our y term on the same side and the constant on the other side. So let's start with that y equals negative x plus 3. I want the x and the y to be on the same side. So I'm going to add x to both sides to give me x plus y equals 3. So now I have both the x and the y on the same side and the constant on the other side. And that is standard form. This question says, evaluate the function f of x equals x squared plus 3x minus 8 at the given values of the independent variable and simplify. So our independent variable is 4. That 4 gets substituted in for x, and we're finding the y value, f of 4. So our function is f of x equals x squared plus 3x minus 8. If I want to find f of 4, see 4 is going in place of x. Everywhere I see an x, I change it to a 4. So that's 4 squared plus 3 times 4 minus 8. And I want to simplify following order of operations. 4 squared is 16. 3 times 4 is 12. 16 plus 12 would be 28. Minus 8 would give me 20. I'm going to do the same thing with the next one. So the next one is f of x plus 2. Everywhere I see an x, I change it to x plus 2, so that would give me x plus 2 squared plus 3 times x plus 2 minus 8. I'm going to work out x plus 2 squared to be x plus 2 times x plus 2. We can use the distributive property, distributing the 3. That's 3x plus 6, and carry down that minus 8. Then let's multiply out x plus 2 times x plus 2. That's x squared plus 2x plus 2x plus 4. Carry down that 3x, and I can go ahead and combine the 6 and the negative 8 to be negative 2. I'll combine like terms. Carry down the x squared. I've got 2x, and 2x is 4x. Another 3x, that would be 7x. And then the 4 minus 2 would give me a plus 2. So that's f of x plus 2 is x squared plus 7x plus 2. So you notice that when we substituted in a number to the function, we got a number as the answer. But when we substituted an expression with x, our answer still had an x in it. So the same thing's going to happen with our next one, which is f of negative x. Everywhere we see an x, we change that to a negative x. That's negative x squared plus 3 times negative x minus 8. Negative x squared is negative x times negative x. We have a positive times a negative, which will be a negative 3x. Carry down that minus 8. Negative times negative will be a positive, and x times x is x squared. Carry down that 3x, carry down that minus 8, and that's our answer. F of negative x is equal to x squared minus 3x minus 8. The graph of the function h of x is shown. Find the function values h of 1, h of 3, and h of 4. So we have to understand this notation, h of 1. The 1 part is the x value, and the h of 1, the whole symbols together, means y. So we want to read the graph by finding an x value of 1 and then figuring out what that y value is. So for h of 1, I'm going to go to the graph and find an x value of 1, go up to the graph and over to the y value. So that y value is 2. H of 1 equals 2. So then let's do h of 3. I'm going to go to an x value of 3, go up to the graph, then over to the y value to get 6. H of 3 is 6. All right, let's do h of 4. I have an x value of 4, go up to the graph, over to the y value, and that's a y value of 5. H of 4 equals 5. So essentially this is very similar to an ordered pair, telling you the x value and the y value. We just use a little bit different notation. This question says, classify the given function as a polynomial function, rational function, or root function. Then find the domain and write the domain in interval notation. So our function is f of x equals 2. So I've got this table on the right that describes the different types of functions that we're working with. And we have rational functions. Rational functions are going to have variables in the denominator. Our radical or root functions are going to have square roots or cube roots. And this example that we have doesn't have a variable in the denominator and it doesn't have a radical. And then when we're looking at polynomial functions, the main thing is when you have a variable, that variable needs to have a nice whole number power. And the whole number powers are these right here, 0, 1, 2, 3. This one doesn't even have a variable, but it's still considered a polynomial function. So we can consider it to be 2x to the 0 power because x to the 0 power would be 1, which is the same thing as 2. So we have a polynomial function, and what we do is we memorize with polynomial functions that all polynomial functions have a domain of all real numbers or negative infinity to infinity. So that is our domain, negative infinity to infinity. This question says classify the function as polynomial, rational, or root. Then find the domain and write the domain in interval notation. So our function is h of x equals 5 over x squared plus 36. Rational functions have a variable in the denominator. Radical and root functions have a square root or a cube root. And we can see that we do have a variable in the denominator for this one. So I would classify this as a rational function. Now with rational functions, we're worried about that denominator not equaling 0. So what we do is we take that denominator and we set it equal to 0 to figure out any restrictions. So our denominator is x squared plus 36. We're going to set that equal to 0 and solve. So I subtract 36 on both sides. That gives me x squared equals negative 36. Get rid of that square by square rooting both sides. The square root and square cancel each other out, but I gain a plus or minus symbol on the other side. Square root of 36 is 6, and square root of a negative would give me I. So because our solutions came out to be I, we don't have any real numbers to exclude. So since we don't have any real numbers to exclude, we are still going to have the domain of negative infinity to infinity. This question says classify the function as polynomial, rational, or root, then find the domain and write the domain in interval notation. So our function is g of x equals the 6th root of 4 minus x. And we've got here on our chart different types, radical or root with an even index or an odd index. We have an even index. So we do have a root function because it's got a radical, but we have an even index root. With even index root, we want to take what is underneath the radical and set that to be greater than or equal to 0. So we take what's underneath the radical, set that greater than or equal to 0. Now, greater than 0 and equal to 0 are both positives and 0. What we're leaving out by doing this is less than 0, which is negatives. If we take the square root of a negative or an even root of a negative, we're going to get imaginary numbers. So we only want what's underneath the radical to be positive or 0, greater than 0 or equal to 0. Then we solve, we subtract 4. That's negative x is greater than or equal to negative 4. divide both sides by a -1, we get an x. Because we're dividing by a negative, we reverse the inequality sign and get x is less than or equal to 4. So we would mark out 4 on our number line, and we were going to put a filled-in dot, and that's because we have the equal to there. So 4 will be part of our domain, part of our set. And then we're going to shade the numbers that are less than 4, which is less to the left of 4, and then write our interval notation. With interval notation, you want to write a lower bound. The lower bound on this one, because this arrow goes on forever, will be -infinity. And then our upper bound, our stopping point, will be at 4. We separate those values with commas. We always put a parenthesis next to infinity, and we're going to put a bracket on the 4, indicating that 4 is part of the set included in the domain. So we have a domain of -infinity to 4. This question says, determine the intervals for which the function is increasing, decreasing, and constant. So we have this picture here, and these words of increasing, decreasing, and constant, they're all describing the y values. So what we want to do is we want to trace the graph going from left to right. The reason why we go from left to right is because we want to go on the x scale from smallest to largest. So that would go from left to right. We're going to trace the graph from left to right. And as we go, we're going to figure out what's happening to the y values. So as we trace along this piece here from left to right, the y values are getting larger or increasing. So I'm going to label this as increasing. And then we get to this point right here, this little peak, and it starts changing. As I trace this piece, now the y values are getting smaller. So this I'm going to label with decreasing. When we get to this little valley, it changes again, and now the y values are increasing. So I'll label that with increasing. So we want to write down where the function is increasing, decreasing, and constant. Notice that we didn't get any sections where it was constant, so we're going to say none on that one. And then when we write down these intervals of increasing and decreasing, we want to make sure that we're using the x scale. The x scale is sort of like our map. We say, look at the graph at x equals 5, and you go to x equals 5, and you start looking at the picture at that point. So when we write down our answers here, we want to write down x values. So when I look at this section right here, this section we labeled as increasing. Where do the x values start and stop for that section? So the x values will start over here at -infinity and stop when we get to -3. We're going to use a parenthesis on infinity. We also have another section of increasing which started right here at an x value of 3 and continues all the way to this x value of 10. So from 3 to 10, we have another section of increasing. I'll separate those answers with a comma. Then we have a section of decreasing right here. And that section of decreasing started at -3, an x value of -3, and stops at an x value of 3. So from -3 to 3, we have decreasing. So remember that these words, increasing, decreasing, and constant, are referring to what's happening with y. But when we write down our intervals, we write down the x's because that's the where part. For this question, it says, for what values of x does the function obtain a relative minimum? find the relative minimum value. For what value or values does the function obtain a relative maximum? Find the relative maximum value. So a relative minimum and relative maximum, those are going to be the highest and lowest values, but in a localized area, localized interval. So what we're really looking for is not the lowest y value on the whole picture or the highest y value on the whole picture. We're looking for little peaks and valleys in the graph. So that's what we mean by relative. If we narrow our focus, to only this part of the picture relative to that area, we do have a maximum. And if we narrow our focus to this part of the picture, we do have a minimum. So we're not looking for the highest overall or the lowest overall. We're looking for those little peaks and valleys, those localized minimums, localized maximums. So let me erase my markings. And this peak that we have right here will be the location of my relative maximum. And that ordered pair has an x value and a y value. The x part is the where part, which is what's being asked in this part right here. For what values of x does the function obtain a relative, well, this is maximum, obtain a relative maximum, and then find that relative maximum. So this part C is asking for the x, and the part D is asking for the y. So you're going to answer for part C, -7, and for part D, 7. So this is the maximum value, and this is the location, the x, at which the maximum occurs. So then this little dip right here, this little valley, that's going to be our relative min. That's happening at the ordered pair -1, -2. So that x value is the where part, and the y value is the actual min part. So for part A, we're going to say at x equals -1, that's where the minimum occurs, and then the actual minimum, relative minimum, is -2. Use the graph of the known basic function and a combination of horizontal and vertical shifts to sketch the function. Our function is h of x equals square root of x minus 1 plus 1. Now this is the graph of f of x equals square root x. That's the basic graph. Notice that it doesn't have this -1 and the +1. It only has the square root of x. This is what the picture looks like, but I want to make sure you understand where this picture comes from. It comes from plotting points. If you choose some x values, plug them into that function square root of x, you'll get the y values and get this picture. For this function, because it's square root, we want to take the square root of only positive values or 0, so I'll start with 0. And then when I choose my positive values, I don't have to, but I want to choose values of x that it's easy for me to take the square root of, that I don't need a calculator for. So numbers like that are perfect squares, like 1. Square root of 1 will be 1. Square root of 0 will be 0. Then maybe 4. Square root of 4 is equal to 2. And then 9. Square root of 9 is 3. So you can see on our picture here, 0, 0 is that first ordered pair, 1, 1, 4, 2, and 9, 3. And so once we get those points, we connect those points with a straight, not a straight line, a curve to see the pattern, and you get that picture. Now, what we want to do is with this -1 and +1, this -1 and +1, that changes the graph. It's going to shift the graph horizontally and vertically to a new position. So let's go one by one. This -1 that's inside, that -1 is a horizontal shift. I know it's a horizontal shift because it's inside the radical. And I know it's a horizontal shift because it's subtraction. So the subtraction part is what makes it the shift, and the fact that it's inside is what makes it horizontal. And then because it's a -1, a minus moves to the right. And we're going to go to the right one. The +1 is also a shift. Shifting is when you have any adding or subtracting. So I know because I'm adding, it's a shift. Because that +1 is outside the radical, I know it's vertical. So because that +1 is outside of the radical, it's a vertical shift. Now because it's a plus, it's going to go up 1 unit. So I want to take my graph and I'm going to move all the points to the right one and up 1 to get the new graph. So if I do that, to the right one and up 1, my picture would move like this. So we would get this answer. This question says, use the graph of the basic function and a combination of transformations to sketch the graph. We have the function g of x equals 2 times the absolute value of x minus 1 minus 3. So we want to start off with the basic graph of y equals absolute value of x. I'm going to make a picture or make a chart of x's and y's. Choose my x's to be -2, -1, 0, 1, and 2. This is just a standard set of points that I always choose to make sure I get a few negatives, a few positives, and 0. I'm going to substitute these values into the absolute value of x. Absolute value of -2 is +2. Absolute value is distance from 0. So that distance is always going to come out positive or 0. Absolute value of -1 is +1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So now we have a set of ordered pairs, and we can draw the graph. We have 0, 0, 1, 1, 2, 2, -1, 1, -2, 2, and we get our V-shaped graph of y equals absolute value of x. And that's why you can see all these answer choices have this V-shaped graph, because we start with that because the absolute value is there. And now if we look at our function, we have g of x equals 2 times the absolute value of x minus 1 minus 3. And each one of those, the 2, the -1, and the -3, are going to cause transformations to the graph, changes to the graph. So let's go one by one. Let's start with the -1. Okay, the -1 is, first of all, a shift. Okay. I know it's a shift because it has adding and subtracting. I know it is a horizontal shift. Okay, so let me go back. Shifting, I know, happens when you have adding or subtracting. I know this is a horizontal shift because that -1 is on the inside of the absolute value. And then because it's a minus, I know that I'm going to go to the right 1 unit. So that's my first transformation, is I'm going to shift the graph 1 unit to the right. So if I were to do y equals absolute value of x minus 1, that's the only transformation, that -1, that will take all of the points that we see here on this graph and move them over to the right. So right 1 unit, and it will be a graph that looks like this. Still a V, but shifted to the right 1 unit. Okay, so then let's look at that next one, which is 2. Okay, so that 2, it's not adding or subtracting, that 2 is multiplied. So instead of being a shift, what we have is something called a stretch or compression. So because it was multiplying by a number, that's why I knew it's a stretch or compression. That 2 is on the outside of the absolute value, so it's going to be a vertical stretch or compression. So that's because it's on the outside. Now, because I'm multiplying by 2, which is greater than 1, I know this is called a stretch. So what's going to happen when we put that 2 into our graph stretches vertically, becomes skinnier. So then the last transformation is this -3. The -3 is going to be a shift. I know it's a shift because shifts are when you have adding or subtracting. That -3 is on the outside of the absolute value, so I know it's going to be a vertical shift. So I know that because that 3 is on the outside of the absolute value. And because it's a minus, I know that my shift is going to be down 3. So because it's a minus. So I'm going to take that blue graph that I've drawn, which is a skinnier absolute value, and shift it down 3. And that will be my final graph, y equals 2 absolute value of x minus 1 minus 3. And so that looks like answer choice B to me.